On this next moments question, we have a uniform rod that is hinged at point P. It is in equilibrium. That means when we take our moments, our clockwise moments are going to equal our anti-clockwise moments. We've got this force here at the end of the rod that is keeping it in equilibrium. We're told that the rod is 3 meters long and it has a mass of 8 kilograms. We want to use that information to find the size of this force. We're going to take moments somewhere. Let's take moments at P. And remember, if there were any forces happening at P, a reaction force or maybe friction, then they would not create a moment because the distance from this point is 0. Okay, so there's no forces that are at P that would create any moments. So my clockwise moments are going to be created by the weight of the rod. Now, this is acting vertically downwards. What I actually want to find is this length here. If I extend this down, I've made a right angle triangle here. Let me just draw it out for you if you're not sure. I want to try and find this length because then I can multiply the force by the perpendicular length. Now, what do I know about this? Well, if the whole rod is 3 meters long and it's uniform, so the weight acts in the center, then this length here is 3/2. Using trigonometry, I want to find the adjacent side. That is the hypotenuse times cos of the angle. So it's 3/2 cos 50 is this length. Okay, so to get my moment, I do force times perpendicular distance. That is 8g times 3/2 cos 50. Then my anti-clockwise moment is created by the force F. Now you can see this angle here is 90 degrees. So actually this force is perpendicular to the distance, the length of the rod. So it's just F, the force, times the distance, which is 3. That was much more straightforward because it is acting perpendicular to the length I have. We're in equilibrium, so those two things are equal. So I've got 3F equals 8g times 3/2. So that is 12g cos 50. And then I can divide by 3. So F is 4g cos 50, which I can then work out. So 4 times 9.8 times cos 50, which is 25 newtons to 2 significant figures. So the main things about that question is that moments are force times perpendicular distance. And we used it in 2 different ways. I used some right angle trig to find this length to give me the perpendicular distance of this force from P. And here we actually had a force that's perpendicular to the length of the rod. So you just do F times 3.